Welcome to Educational World. In today's video lesson, we'll be looking at a typical physics NECO practical electricity question for this year 2020. I read the instruction to the question. Connect the circuit as shown above. Set the value of R to be equal to 1 ohm. Close the key and obtain a balance point P on the potentiometer wire AB. Read and record the length AP, which is equal to L. Evaluate the inverse of L. Repeat the experiment for R equal to 3, 5, 10 and 15 ohms respectively. In each case, determine and record the corresponding values of L and the inverse of L. Tabulate your readings. Plot the graph of R on the vertical axis and L inverse on the horizontal axis, starting both axes from the origin. Determine the slope S of the graph and its intercept I on the vertical axis, and evaluate K, which is equal to the inverse of the intercept. State 2 precautions taken to obtain accurate results. Okay, now we are gonna begin. So this experiment is pretty easy to outsmart, but we cannot be able to do so, without performing the first of the set of experiments. And why do we do that? This is to enable us to get some necessary values that will be helpful for us. Don't forget that this is not the real NECO practical question, but I believe that it's going to look similar to this format. So I want you just to learn the tricks involved here. Okay, just learn the tricks. But I believe that the question is gonna look like this, probably. So we begin. Now let's assume that we have gotten our first experimental values, either by performing them or generating or getting the readings from our friends. Now the values gotten are as follows. When R is equal to 1 ohm, then we have that L is equal to 65.0 centimeters and the inverse of L is equal to 0.0153 per centimeter. Okay, now there is a relationship between resistance of a wire and its length, and we can find this relationship in this formula. R is equal to rho L over A, where R is equal to the resistance, rho, which is a constant, and A, they are all constants, and L is the length of the wire. So we can simply rewrite equation 1 to be as R is equal to KL, where K is equal to rho over A. So now the constant K is now equal to R, resistance all over the length. So this leads us to a special relationship which we use throughout this experiment, that R1 over L1 is equal to R2 over L2. Now when we have set the resistance in the resistance bus to be 3 ohm, now we are now going to employ this relationship here. Okay, now which, cut it again, R1 over L1 is equal to R2 over L2. Now which one is R1 and which one is R2? Now L1 is the length we are trying to look for, which is the L, which is the distance AP. As you can see, the L2 as indicated there is 100 minus L. R1 is the unknown resistance labeled X, which is equal to 2 ohm. Don't forget that. And R2 is the variable resistance which will be changing from our resistance bus. So when we substitute the values where necessary, we now have that 2 over L is equal to 3 over 100 minus L. So simplifying that, we now have that 200 minus 2L is equal to 3L. So simplifying to get the value of L, we now have that L is equal to 40.0 centimeters. And then we go to our table of values. Now input it. I will now say that when R is equal to 3 ohm, L is equal to 40.0 cm, and L inverse is equal to 0.0250 per centimeters. Now this follows the same trend. So when R is equal to 5 ohm, we still use the same trend, the same thing we've gotten, is that same relationship. Okay, R1 over L1 is equal to R2 over L2. Don't forget that L1 is the distance AP, L2 is the other distance BB, which is 100 minus L. R1 is the unknown resistance labeled X, which is 2 ohm, and R2 is the variable resistance, which is for now 5 ohms. So we are going to substitute these values where necessary into the relationship we have above. So 2 over L is equal to 5 all over 100 minus L. So we are going to simplify again to find or evaluate the value of L. So simplifying to evaluate the value of L, we now have that 200 minus 2L is equal to 5L. So it means that therefore L is equal to 28.57 centimeters. So we now move over to our table of values, and inputting it, we have that when R is equal to 5 ohm, L is equal to 28.57 centimeters, and the inverse of L is equal to 0.035 centimeter. Now the same trend continues when R is equal to 10 ohms, still using the same relationship, which states that R1 over L1 is equal to R2 over L2. Remember, L1 is the distance AP, which is L, and L2 is the distance BB, which is 100 minus L. R1 is the unknown resistance X, which is 2 ohm, and R2 is the variable resistance, which is for now 10 ohms. So we now substitute all these values where necessary into the relationship we have, which gives us that 2 over L is equal to 10 all over 100 minus L. So we now simplify and look for or find the value of L. This is a very simple calculation. So performing that, it leads us to 12L is equal to 200. Therefore L is equal to 16.67 centimeters. So we move over to our table of values, and computing it, we have that when R is equal to 10 ohm, L is equal to 16.67 centimeters, and the inverse of L is 0.06 per centimeters. Now finally, when R is equal to 15 ohms, still using the same trend and the same relationship, R1 over L1 is equal to R2 over L2. By now you already know what R1 and R2 mean, and L1 and L2 what they stand for. Okay, so we are now going to substitute the necessary the values we have into the relationship above where necessary. Okay, and in doing that, we now have that 2 over L is equal to 15 all over 100 minus L, and simplifying, we have that 2 open bracket 100 minus L is equal to 15L, and try to open the brackets and collecting like terms, we now have that 17L is equal to 200. Therefore L is equal to 11.76 centimeters. Now we move over to our table of values, and computing our table of values, we have that when R is equal to 15 ohms, L is equal to 11.76 centimeters, and the inverse of L is equal to 0.085 per centimeter. And immediately we move over to graph plotting. Before we plot our graph, observe the uniform decimal placement in our table of values, and also don't forget that the heading of your table of values must contain the necessary units. So this is a graph of R against L inverse. The slope of this graph is change in R over change in L inverse. Now we are taking 2 points here. We are taking the points 10 and 3, and also the corresponding values in the horizontal axis, which is 0.06 and 0.025. So solving for the slope, we now have that the slope is equal to 200 ohm per cm. So the intercept on the vertical axis I is equal to minus 2.1 ohm. That is where the graph cuts the vertical axis. And evaluating for the inverse of the intercept, we now have it as a minus 0.48 per ohm. So if you have any questions or where you find confusing, you can comment on the comment section below and I will attend to you. Thank you for watching.